At this point in my 640 by 480 video card build, I need to put some thought into how I'm going to manage the decode logic beyond what I've done up to this point. So as a reminder, in my 286 address space, I have a 64K window. And with that 64K window, I can access the full 2 meg of the video card, which is broken into 2 frames, frame 0 with a meg, frame 1 with a meg. And then I have the VGA output circuit that can read the first half meg of either of those frames to actually do the rendering. And I think I can change that in the future, but that's currently how it's set up. And I have this register, this 16-bit register that I've added to the circuit that allows me to set the configuration, or the control basically. So which frame is the 286 using versus the VGA out using, along with which 64K segment within that frame is the 286 using basically. And up to this point, I've built the register, I've built frame 0, so the first frame is there and I can access that from the 286. I've not built any of the VGA output circuitry yet, and I'm soon going to be hooking up the additional frame 1. But really, for all of that to start working together, I need to have all of this decode logic figured out. So this video is probably going to be a little rambly. I'm going to do an intro here, and then I'll just jump into maybe some rambling thoughts. Take it for what it's worth, and if you have thoughts or feedback, feel free to chip in, and I'll be doing some experimenting here in the days and weeks to come. I'm going to just flip to this graphic here. I've got my 286, I've got the VGA out. They both want to access this memory, and the way I'm trying to work with this is that the 286 will get control of one, the VGA out will get control of the other, and they can then be toggled back and forth. So the 286 can write to memory while the VGA out is using the opposite frame, and then I can swap that and update accordingly. Now, each of these frames is made up of a pair of static RAMs. There's a high RAM and a low RAM, and this kind of goes back to 286 architecture and how that was typically done. So I'm just following that as far as this is concerned. So my 286 is going to access those memory in full 16-bit, or be able to access it as a 16-bit data piece, or just the high or just the low. Whereas the VGA out is just going to have to serially roll through low to high addresses, which means it's going to be toggling back and forth between the low and the high static RAM as it's reading for its output. But if I maybe reorganize this a little bit and just say, okay, I've got 2 different essentially devices, the 286 and the VGA output, that want to access this RAM, how am I going to control that? So I have muxes, these multiplexers. There's one that gives access to frame 0. There's one that gives access to frame 1. And when I say 1, it's actually 5 ICs in each of these multiplexers that makes up access to get to those pair of static RAMs. So there's 10 different multiplexers just represented with these 2 boxes. And those allow me to choose, for example, which one is the 286 going to be talking to, the upper frame or the lower frame, frame 0 or frame 1, and then the VGA output should be using the opposite. I also then have another mux on the output side, so that on the left it's more of which addresses make it into those RAM chips, but then which data am I going to read out. I have another mux that allows me to choose, am I pulling data out of frame 0 or frame 1 to send out to the VGA output? And then again, that allows me to choose one of these or the other for that output. I then also have a transceiver that allows the data to and from the 286, so that the 286 can send in its addresses to the appropriate frame and then get access to the appropriate data for that frame data. And that's made up of actually 4 chips, basically. There's 2 different sets, one for frame 0, one for frame 1. But then I can now say, hopefully through the registers, those specific transceivers, which frame are they going to actually connect to the 286. And so there's a lot of arrows here, which means there's a lot of choices, and I have to be able to dynamically be flipping this around as I write code from my 286. And the way I can control most of these are through the following flags. So With the multiplexers, there's a choose A or choose B. So you've got two different inputs. You have an A input, a set of A inputs, a set of B inputs. I can choose one or the other. And if I feed that a low, it chooses whatever's hooked up to A inputs. If I choose high, it chooses whatever's hooked up to the B inputs. And so I can use that to control those muxes. When it comes down to the transceivers, I've got a couple of pins that I can use. There's a direction, because I might be writing to the RAM or I might be reading from the RAM. So I have to choose which direction, and then output enable, which is an active low. That allows me to choose, am I actually going to output the transceiver or basically just disconnect those signals. When it comes to the RAM, there's a few different signals that I have to work with. There's first of all one that says whether or not I'm writing to the RAM or allowing writes, and so that's an active low write enable. There's an active low output enable, should it send out information from the RAM. So you're going to typically have one or the other. You're either going to be writing or you're going to be reading. So one of these would be low. And then there's also a chip enable, and that allows me just to say, do I simply turn off the chip and I don't read or write? I don't allow any of that. It's just sitting there. And so I have those signals that I can work with. Kind of the idea here though is the 286 would say, okay, I'm going to go ahead and use frame 0, and so I would have to set the AB accordingly on that mux. The transceiver I'd have to set to make sure that the appropriate data coming out of that frame 0 is making it back to the 286 and in from the 286, and then the VGA out, it needs to be on the opposite frame, and so that it can be outputting while I'm still working with frame 0. And I should be able to then toggle and switch this around, and same type of concept. But all of this along the way, I've got to make sure I am using the right signals for the AB, the write enable, output enable, chip enable, direction, etc. And so that is a little bit of a brain twister as I get into this. And so I'm starting to think through that. And now there's a little bit more complexity on top of that. You know, if my 286 is accessing a frame like here, it might access just the low byte, just the high byte, or both bytes. And typically the A0 address along with a signal called BHE is used to determine, am I trying to read just the low, just the high, or an entire word, both bytes at once. Whereas on the VGA output, there is no 16-bit or 2-byte read on that. I'm sequentially going byte by byte. So it's going to read the low byte, then the high byte, then a low byte, high byte, and it's just going to basically work its way through the addressing accordingly. That adds a little complexity because now I don't have a BHE when it comes to the VGA signal, but I can just simply use the A0 signal to help me understand, should I be in the low or the high. But it's not A0 from the system, it's A0 from the video address generator. So my A0 for these chips is going to change depending on whether the 286 or the VGA out has current control of that specific set of RAM, that frame. So those are the types of considerations that I have to think about. So I'm going to switch over to my actual design files. And so here's my current schematic, and just again to talk through what I was just showing there in the visuals. I have a register down here in the lower left that's going to let me bring in and store basically these options right here. And this is what I'm going to be using for now. I've kind of cleared out the rest of this stuff just to make this more clear. But I have 4 bits to choose which segment, so that's giving me 16 combinations. That's will let me basically choose which of the 16 segments of 64K within each of the megabytes of frame 0 and frame 1 do I want to actively use. And this is from the system, from the 286 perspective. And then I'm also specifying from the system perspective which of the frames is currently active. And I've taken away the option to choose which one is output. Since I only have 2 frames, I'm just going to force it. If you choose 1 frame for the 286, it'll automatically pick the opposite frame for output on the VGA side. And as I toggle bit 4, it's just going to basically swap what has access to frame 1 and what has access to frame 0. So that's my register down there, and if I come up here a little bit, here are those multiplexers. And if I zoom into the multiplexers, you'll see that there is this /AB. So if I give it a low, it's going to pick my A, which is addresses from the 286. If I give this a high signal, it's going to grab the addresses from my video address generator, which is a PSOC that I've not yet hooked up. If I scroll to the right a little bit, on the output side of things, going to the VGA, same thing, multiplexers. I have a signal that I can choose, which frame am I using for the output. And when I come down here, I have my transceivers for, do I connect one frame or the other, which frame basically is connected to the 286, and in which direction. So I have a read-write. That's going to let me choose the direction. So am I writing in or reading out? And then I have this VGA 286 symbol that, or signal that I can put here that basically lets me choose whether I should be outputting or not. And the outputting could be coming in or going out, either way. And a lot of these things I'm setting up separate signals to get going. Maybe later it's just simply an inversion of a signal that I use, an inverted signal, and not have to have separate signals, if that makes sense. But I'm trying to make this more mentally digestible for myself for now. And then in the middle, I've got a pair of RAMs. That's frame 1. Up above it is frame 0. But if I go look at one of these frames, as far as the memory, you can see this is frame 1. And so I have my write enable, I have my output enable, I have my chip enable. And these are F1 write enable, F1 output enable. And then I have to make sure I understand whether I'm reading the high, the low, or both. And again, that really matters when the 286 is using it. So in this case, I have an F1 high chip select and an F1 low chip select. And you'll see that I repeat that same thing up here on the frame 0. So I've got common, write, or reads, but then am I using the high or the low? I've had to separate that. So I've got 1 signal, 2 signal, 3, 4 different signals for frame 0, and I've got 4 different signals for frame 1, along with the signals that you've seen over here, which would be a 5th signal, to the right, a 6th signal, and then down below, adding to that, I have the frame 1 write enable already, so I don't have to count that again. And then I've got this signal already. So I've got 6 signals at least on the output so far that I think are going to help me be able to swap this stuff around depending on how the register is set. So then that's going to get me into the PSOC configuration. And if I jump over to that for a second, have something that might look like this. So this is my PSOC for the decode logic, and I doubt this is quite right yet. So I'm just kind of putting this out there for those that are interested in where my thoughts are right now. As I get in and actually start testing this, I'll see how much of this actually is valid and works, and what I need to kind of come in and rethink. But maybe if I jump over to the upper left, oh, and I will post this on my blog if you want, if anybody is interested in looking at it more, but I wouldn't get too worked up about it unless you see something that really looks obviously wrong quickly at this point, just because I will be testing this and probably adjusting this. But in the upper left, I'm trying to just capture all the different inputs I have coming in from A7 down to A0. I have another pair of ICs in my circuit that just let me know if I'm in the address space for the 64K segment for the video addresses in general. And then I've got signals from the 286 of whether or not I'm doing an IO reader write, a memory reader write. Here's that BHE signal I mentioned before. Reg4 is the register that lets me choose which frame number. VA0 is the address 0 coming out of the video address generator. And then the sync signal I'm also bringing in, again, from that video signal generator, that other PSOC. So not this PSOC, but the other PSOC, which looks like this. And I've shown this in the past. I've not updated this yet. I've got some adjustments on these numbers to do, but I generate my horizontal, vertical, and just some output enable type signals for the video. But over here, I'm working on the kind of the decode or the logic type of PSOC. And ultimately, I need to take these input signals and then generate all of those other ones that I was kind of walking through the schematic. So I've got F0, frame 0, the RAM. Should it be outputting or should it be writing? Frame 1, should I be outputting or should I be writing? For frame 0, am I currently set to the 286 or the VGA? So if it's low, I'm setting it to 286. If it's high, I set it to VGA. And then I've got a corresponding F1 signal. On the output side, the way that that is currently set up, it's kind of the opposite of the value you set it. So if I give it a 0 for this value of VGA out frame, it actually outputs frame 1. And if I set this to 1, it actually outputs frame 0. So as an example here, if I come in and I say, I read my register and the register says use frame 0 for the 286, that'll put a 0 in here, making the 286 active and the VGA not active for frame 0. And then this is going to output on the opposite. So frame 1 then would be used by the VGA. And then I've got some logic in here that just basically says, okay, if ignore this over here for a second, I'll come back to that, but I'm reading in this register. If the register is low, I'm going to have the 286 be controlling F0, which means for the RAM write, I'm going to use this normal memory write signal. And for the RAM output, I'm going to use this normal memory read signal. So if I set this register to a 0, that means that 0 is going to come in here, and I'm going to set this signal to a low, telling the 286 it has control of frame 0. And at the same time, I know that the VGA would not have access to this. And in this other branch of logic, the VGA would control the frame 1. And I kind of had those as opposites. You can see an inverter here. So I'm bringing in a signal, net reg 4, and then two opposite branches here, one for F0, one for F1. But that says if I come in and I do set this to a 0, the 286 has access to frame 0. And then I come up here with these multiplexers and I simply say, okay, for then the RAM writing, use this signal. For the RAM reading, use this signal. But if I would have set this register to a 1, meaning that I want frame 1 to be used by the 286, that means that frame 0 is accessed by the VGA output. And if that's the case, I'm just going to set the writing to a 1, so the VGA will never write to RAM. And then I want to always be outputting, so that just simply says constantly output the values on frame 0 for the VGA output. And then I have to come in here too and choose whether or not I'm going with a high or a low. This is for those chip enables. So let's assume that I come in and I say that the VGA is on frame 0, and then I get into this and I say, okay, go ahead and check if I'm in the address space of the VGA 64K address space and my A0 is a low, then I want to basically send out to my low enable this inverted signal. So basically I'm going to use, all I'm doing is I'm using this as a filter to only enable the chip if I'm in the right address space. And if A0 is low, pass that A0 through for my low chip enable. And over to the right is kind of the same thing. It's just I'm checking for BHE. And so make sure I'm in the right address space and then pass through BHE as what I'm going to use for this chip enable. But if it ends up that the VGA has control of frame 0, then instead I send through this video address 0 coming from my video address generator. So if it's a low, I grab the low byte. If it's a high, then I need to actually invert it so that it is an active low. So if address 0 is a 1, this will invert it down to 0 and pass that through. That 0 now is activating that for output. So basically, as I roll up through a series of addresses, it's going to bounce back and forth between this being active, this being active, this being active, this being active, and that's how it's going to work through those pair of memory chips. And so pretty much that whole thing up here is all the frame 0, and then what you see down below is all of the frame 1 comparable. And then over to the left, I added in this specific component which is a D flip-flop that I'm using. And that D flip-flop, I'm just simply tying it basically to this value of Reg 4, but then tie it to my vertical sync. And if I've got this right, vertical sync is typically high, and then when I'm actually doing the vertical sync, it drops low and then comes back up. I put an inverter here because it's the rising clock edge of this D flip-flop that I'm using. I put an inverter here because it's the rising edge of this clock when it actually brings in the new value, and I want that to happen as quickly as possible, as soon as possible. So when I see the VSync signal transition low, I actually want to start swapping this over. This is basically inverting that, so when it actually does that drop, I'm actually going to be doing a raise of the clock signal, which will then bring in the new value here and flip these things over. So I think that is the way to synchronize this, and what that's going to mean is that from the 286 I can write updates to this register. Those updates will not take effect until I hit the VSync signal, and once I hit VSync, then the actual flip will happen. So I think that is how I'm going to approach that. I believe that is what I was understanding from some guidance. Liquid Nyquist, you had given some input on that at one point, and hopefully this is pretty close to what you were thinking as you were describing that. And then down below here, I still have all of this I/O. That hasn't really changed, so that's there, the same as it was in previous videos. So now I have a register with one setting. With that, I choose which frame the 286 has access to. The VGA output will automatically get the opposite frame. And I'm hoping that the logic I have here will help me then automatically make sure I've got the right signals for these low and high enables, which are all active lows. Also all of these other signals to turn on, turn off, which inputs, I guess, on the multiplexers, and then on my transceivers, whether they're enabled and which direction they're going in. I'm sure I am missing something here yet. This is a little bit of a brain teaser as I go through it, but I think I've got something in the general path. Now, maybe there's a much better way or easier way to do this. If there is a better way I should be pursuing, or anybody has ideas, do let me know. But this is how I'm going to start trying out this logic here in the coming days, is to get the rest of this stuff connected up. I still have frame 1 to hook up, and I don't have any video output stuff hooked up yet. I'm going to try to get frame 1 hooked up and tested with this logic, just to see if I can toggle back and forth. Then I'll hook up the VGA output and see if I can actually get something to show up on the output. That's all I've got for today. I just thought I would share, like I said, ramblings about some of this logic I'm working through, and this wasn't overly scripted, so I know it was a little bit choppy as far as I went through it. So thanks for bearing with me, and thanks for watching.